Hello everyone, I am Dr P Raja Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, I am going to explain some more problems on first order linear equation. So, already we know this, what is a first order linear partial differential equation. So, we'll call this one as a Lagrange's linear equation. So, the equation form is P into P plus Q into Q equal to R. So here P, Q, R are the functions of x, y, z. So here the general solution of Lagrange's equation is f of u comma v equal to 0 or pi of u comma v equal to 0. So here we are going to write the general solution for this. So this is the general solution u comma v equal to 0. So in these two solutions are included, that is u of x comma y comma z equal to c1 and v of x comma y comma z equal to c2. So we are going to discuss some more problems here. See the first one. Form the partial differential equation by eliminating a and b from log of az minus 1 equal to x plus ay plus b. So here given equation is log az minus 1 equal to x plus ay plus b. This is the given equation. So in this one we are going to eliminate constants a and b. So then we can form the partial differential equation. To do that, I am going to do first differentiating partially with respect to x and y. So here equation 1 is going to differentiate partially with respect to x and y. So if take here log az minus 1 equal to x plus ay plus b. First I am going to do the partial differentiation with respect to x. So log x differentiation is 1 by x. So 1 by az minus 1. So here e. Okay. So now we are doing with respect to x, right? So x differentiation is 1 plus a and y is constant and 0 also constant here. So now here log, this is we can written as 1 by az minus 1 into ap equal to 1. So we can write here ap equal to az minus 1. A into p equal to az minus 1. Now I am going to differentiate partially with respect to y. So log az minus 1 equal to x plus ay plus b. So here 1 by az minus 1. Okay. Next we have to differentiate this one. A is the constant, dou z by dou y equal to x is 0 plus a into y is 1 plus 0. Now I got here 1 by az minus 1. A into dou z by dou y is q equal to a. So here I am going to write aq equal to a into az minus 1. Here also app equal to dou z by dou x. So finally a into p equal to az minus 1. This is the equation 1 and 2 I got after differentiating partially with respect to x and y. So now I am going to simplify these two equations. So here I am doing 2 divided by 1. So what is the first equation and second equation? You can observe here. AQ equal to A into AZ minus 1. AQ equal to A into az minus 1. This is the equation 2. And equation 1 is AP equal to az minus 1. Az minus 1. So here this is the equation 1. I am going to do 2 divided by 1. So that means AQ by AP equal to A into AZ minus 1 by AZ minus 1. So here AZ minus 1 will be cancelled. A will be cancelled. Finally, I got Q by P equal to A. Nothing but here AP equal to Q. So here I got after simplification AP equal to Q. Now I am going to substitute this value in equation 1. So what is the equation 1? A into P equal to AZ. Now AP is Q equal to, what is the A value I can write from this? So A equal to Q by P. So Q by P into Z minus 1. So finally I can write this one as a PQ equal to QZ minus 1. So now PQ plus QZ equal to, so now I am taking the common Q here. So P plus Z equal to minus 1. So this is our final solution. We are eliminated A and B. So this is the way to do the problems to get the partial differential equation. Next I am going to one more problem to explain. So see here, solve x square minus y square minus yz into p plus x square minus y square minus z into q equal to z into x minus y. So here given equation is x square minus y square minus yz into p plus x square minus y square minus zx into q equal to z into x minus y. So here I am writing what is p, what is q. So capital P is x square minus y square minus yz. This one. Capital Q is x square minus y square minus zx. R is z into x minus y. So now I am writing the auxiliary equation, that is dx by p equal to dy by q equal to dz by r. Now I am going to replace PQR values, dx by x square minus y square minus yz, dy by x square minus y square minus zx, dz by z into x minus y. So now I replace here P, Q and R values. Now I am going to simplify this to get the solution. First, I am taking the multipliers, that is 1 comma minus 1 comma 0. So that means this is equal to first one, that is dx minus 1 into dy plus 0 by here 1 into x square minus y square minus yz minus 1 into minus x square plus y square plus xz plus 0. So now I can get the value here dx minus dy by, so plus x square minus x square cancel, plus y square minus y square cancel. So here I got xz minus yz when I taking the common. So z into x minus y. So I got here that one is dx minus dy by z into x minus y. Now I am taking one more set of multipliers. Those are x minus y comma 0. First I am multiplying x with the dx. So x dx numerators minus y dy plus 0 by now x into dx. So when I am multiplying with x denominator, so x cube minus xy square minus xyz. Now I am going to multiply with the minus 1 here. So minus 5 into, so x square y minus into minus plus y cube. Next, minus into minus plus xyz plus 0. Now plus xyz minus xyz. Next one is here x cube plus y cube and xy square minus x square y. I am going to simplify this one, x dx minus y dy by, I am taking here this one, we can written as x square minus y square into x minus y. So this is our value after taking multiplies x minus y 0. Now I am taking these last three values. What are those? Dz by z into x minus y. Next, after taking the multipliers 1 minus 1 comma 0, I got here dx minus dy by z into x minus y. After that, using the second set of multipliers x minus y 0, I got here x dx minus y dy by x square minus y square into x minus y. So if I take it directly, I can't do the grouping or if I take only multipliers, I can't simplify this equation. That's why first I am taking the multipliers. After then I am going to do the grouping here. First, I am taking first two ratios. That is nothing but here you can observe dz by z into x minus y. Z into x minus y. This is the first one. And second one is dx minus dy by dx minus dy by z into x minus y. So these are the first two ratios I have taken here, dz by z into x minus y, dx minus dy by z into x minus y. So you can observe here z into x minus y, z into x minus y cancel. I got here dz equal to dx minus dy. Now I am going to integrate integral dz equal to integral dx minus integral dy. So finally this solution I got z equal to x minus y plus some constant. So I am going to write this one as x minus y minus z equal to some constant. So this is our first solution. So now I got the u. This is the u. U equal to x minus y minus z equal to 7. Now I am taking first and last ratio, that is this one and this one. So you can observe here first one is dz by z into x minus y equal to x into dx minus y into dy by x square minus y square into x minus y. These are the first and last or third ratios. Now here x minus y will be cancelled. Finally here I can do this dz by z equal to x dx minus y dy by x square minus y square. Now here x square derivative is 2x, y square derivative is 2y. So now I am going to write this one I am multiplying with 2 on both sides. So 2 into dz by z equal to 2x dx minus 2y dy by x square minus y square. So x square derivative is 2x, y square derivative is 2y. So now here I am going to integrate on both sides to integral dz by z equal to here integral 2x dx minus 2y dy by x square minus y square. So now this is 2 log z equal to this is log x square minus y square plus log c2. So here I am sending 2. I can write this one as a log b. That means a b power log b power a. I can write. So here log z square equal to log x square minus y square plus log c2. Now I am going to write this one as log z square minus log x square minus y square. So that is equal to log c2. So here log a minus log b. So that means I can write this one as log a minus b, right? So z square. Otherwise, x square minus y square equal to log c2. Otherwise, you can write this one as log of x square minus y square by z square equal to log c2. So finally, log will be cancelled. I got x square minus y square by z equal to c2. So now, this is the this is v. So v equal to x square minus y square by z square equal to c2. So now I got u equal to x minus y minus z equal to c1 and v equal to x square minus y square by z square equal to c2. Now I am going to write the solution f of u comma v equal to 0. So now write the general solution, that is f of x minus y minus z by x square minus y square by z square equal to 0. This is our general solution. So here, so many different problems are there. Some problems we can solve by using the only grouping method. Some problems we can solve by using only multipliers method. Some problems we have to use grouping and multipliers together. After then you have to solve. So those problems we are solving now. So we have to understand first how we can do the simplification to get the solution according to the procedure. This you have to remember. Next we are moving to next one. That is solve z square minus 2y minus y square into b equal to plus xy plus zx into q equal to xy minus zx. So given equation is z square minus 2yz minus y square into p small p plus xy plus zx into q equal to xy minus zx. So here I am going to compare with the Lagrange's equation, that is p plus p plus q into q equal to r. So now I am writing here what is the capital P, z square minus 2yz minus y square. What is q? Q equal to xy plus zx. What is r? R equal to xy minus zx. These are the P, Q, R values. We are going to replace in auxiliary equation, that is dx by P equal to dy by Q equal to dz by R. So dx by P is z square minus 2yz minus y square equal to dy by xy plus zx equal to dz by xy minus zx. Now I am going to take the multipliers. Those are x, y and z. So we are going to multiply this one. So here you can observe this is equal to here x into dx numerators plus y into dy plus z into dz. So now I am going to multiply this one, first one denominator with x. So now, so x into z square minus 2xyz minus xy square. After that, we are going to multiply with y. So plus xy square plus x square z. So here this one is x, I am multiplying here with the y, right? So first one is xy square, second one is xyz. Next we are going to multiply third one with z. So plus xyz minus xz square. So now here minus 2xyz plus xyz plus xyz. Here xy square, xy square, xz square, xz square. So finally we got here x dx plus y dy plus z dz. Denominator is 0. That means x, y, z are the multipliers. So we can take the solution of integral x dx plus integral y dy plus integral z dz equal to some constant. So integral x dx is x square by 2 plus integral y dy is y square by 2 plus integral z dz is z square by 2 equal to some constant. So finally I can write this one as x square plus y square plus z square equal to 2c1. I can write this one as a complete c1. So finally I got here x square plus y square plus z square equal to ARC. This is my first solution. I can write this one as u equal to x square plus y square plus z square equal to a. This is my first solution. Now I am going to take here first one I got from the multipliers. Now I am taking second member and third member. So second member and third member is here dy by xy. I am taking the common here yx into y plus z equal to dz by, here taking x common, y minus z. So x will be cancelled here. So we are doing here cross multiplication. So what is that? Y minus z into dy equal to y plus z into dz. So now I am doing here y dy minus z dy. I am sending this one to the right side, minus y dz minus z dz equal to 0. Now y dy minus, here taking minus common, so minus, so y dz plus z dy. Next one is minus z dz. So now I am writing this one as y dy minus y dz plus z dy minus z dz equal to 0 I got. So now I am writing this one as y dy minus this one I can write it as d of derivative of y comma z or y z minus z dz equal to 0. Now I am going to integrate. So integral y dy minus integral derivative of yz minus integral z dz equal to some constant. So integral y is y square by 2 minus derivative and the integral will be cancelled. We got yz minus integral z is z square by 2 equal to some constant. So now we are writing here y square minus 2yz minus z square equal to some constant. I can write this one as y square minus 2yz minus z square equal to some constant. So this is my second solution. That is, you can write v equal to y square minus 2yz minus z square. This is the second solution. I got first solution u equal to here x square plus y square plus z square equal to c1. So that is x square plus y square plus z square equal to c1. And second solution will be equal to y square minus 2yz minus z square. This is the B solution. Now we are writing the general solution. F of u comma v equal to 0. That implies f of u is x square plus y square plus z square. Next v is y square minus 2yz minus z square equal to 0. This is our final general solution. So here we done by using the method of multipliers, one solution and one solution from the grouping. So here, so this is the way we can solve the problems. So some of the problems we can get two solutions by using the grouping method. We can get two solutions by using the method of multipliers. Sometimes you can get the solution from grouping method and one solution from multipliers. So we are going to one more problem to solve to get a better understanding about these methods and solutions. Find the integral surface of x into y square plus z into b minus y into x square plus z into q equal to x square plus y square into z. So which contains the straight line, that is x plus y equal to 0, z equal to 1. So here given equation is, so given equation x into y square plus z into b minus y into x square plus z into q equal to x square plus y square into z. Now we are writing in the auxiliary equation a subsidiary equation. So dx by p dy by q equal to dz by r. So what is the p here? X into y square plus z. What is the q here? Minus y into z square plus x. What is the r here? X square minus y square into z. So now here we are going to do the solution by using the set method of multipliers. So first I am choosing the set multiplies x, y, z. We can observe here this one is equal to x into dx plus y into dy plus z into dz by, so x into dx. So x I am multiplying here x square y square plus x square z. This is the first one. Next minus y square into x square minus y square z. Next here plus z into here x square z square plus y square z square. So here I am taking x square y square. So plus x square minus y square. So here z square x square z. So here x square z and y square z plus here also plus is there. So here this one is, and this we have to change here. Here the value is x square. Here minus, this one is minus y square x square. So this is minus y square x square. Next one is minus y square z. So here, now here x square z plus y square z. So plus x square z minus x square z. Here plus y square z minus y square z. So now we are getting here x dx plus y dy plus 1 into dz by 0. So here we can check the value. Now integrate integral dx plus integral y dy plus integral dz equal to some constant. So x square by 2 plus y square by 2 plus z equal to some c. So finally we got here solution x square plus y square minus 2z. So here x square plus y square minus 2z equal to constant. So now I am taking another set of multipliers. Now I am taking another set of multipliers, that is 1 by x. So now 1 by x, 1 by y and 1 by z. So when you are doing this, so 1 by x into dx plus 1 by y into dy plus 1 by z into dz. Now the denominator is x will be cancelled, we got y square plus z. Y will be cancelled, we get here minus x square minus z. Here z will be cancelled, we got here plus x square minus y square. So plus x square minus x square plus y square minus y square. And here z. So finally we got 0. So that means integral 1 by x dx plus integral 1 by y dy plus integral 1 by z dz equal to some constant. So integral 1 by x is log x plus integral 1 by y is log y plus integral 1 by z is log z equal to some constant. So I am writing this one as log a plus log b plus log c is log abc. So log x y z equal to, here I am taking in place of constant with log, so log c2. So this is I am taking as log c2. So finally x y z equal to some c2. This is my second solution. We can observe here. So x square, first solution is x square plus y square minus 2z equals some constant, that is x square plus y square minus 2z equal to some constant. This is the first solution. And second solution is xyz equal to constant. So they given the straight line here. What is that? X plus y equal to 0 and z equal to 1. So we are using this one. So x plus y equal to 0 and z equal to 1. What is the question they are asking here? Here, find the integral surface of this equation which contains the straight lines. So here, x plus y equal to 0, z equal to 1. We are going to substitute these values in this. So therefore, x square plus y square minus 2 into z is 1 equal to e. This is the first one. Next x, y, z is 1 equal to p. So now I am going to simplify this. So a plus 2b I am taking. So this is a, this is 2b. So a is x square minus y square minus 2. This is the first one plus 2 into b. So 2xy. So now here I am going to simplify. I can write this one as a x square minus y square plus 2xy. I can write this one as a x plus y whole square minus 2. So here I can write minus 2. This one as x plus a plus b whole square. It is the formula is a square plus b square plus 2ab. So here if you take in a plus b whole square, here minus 2. So here I can write this one as a square plus 2ab plus b square minus. So this one we are going to simplify to get the value. Here I am simplifying that one as x plus y whole square minus 2. So this is equal to a plus 2b. This is equal to a plus 2b. So now, so a plus 2b plus 2 equal to 0. So now I am going to write the value here. X square plus y square minus 2z plus 2xyz plus 2 equal to 0. So we are substituting the values x plus y equal to 0 and z equal to 1 here. Then we got the required surface, that is x square plus y square minus 2z plus 2xyz plus 2 equal to 0. These are the ways to solve the given equations by using a method of grouping and multipliers. So it will be very clear to us if we follow to calculate the solutions for the partial differential equations. That is nothing but first order linear partial differential equation, that is like this equation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.